We're here to talk through the Sudoku variation called Multiples Sudoku. It's a concept I'm not sure I've seen before, but it's pretty obvious, so I'm not going to claim it's something I invented. But it was a less common Sudoku variation I wanted to include in the Sudoku Grand Prix, and so the idea is that across any of these clues, we form a two-digit number, and this has to be a multiple of the clue that's given. So if a 9 is in the cell, that means this is 18, 1 to the left, 8 to the right, or 27, or 36, or 45, things of that sort. And this is actually the example puzzle I wrote for the Sudoku Grand Prix that's coming up in the start of August. The competition puzzle is similar to this. This is at least a representative puzzle of how to work through multiple Sudoku. One of the things to note in the style is that the isolated groups are not always as easy to work with. The boxed groups where the clues run into each other are far easier. So this clue of boxes is giving you some sense of places to look. And one of the first things solvers will probably notice in a multiple Sudoku, a multiple of 5 always ends in 5. So the 5s can be given straight away in the grid. These boxes then become pretty easy to work through. This 5 has to be a multiple of 7 that works. The only digit that works there is a 3. Multiple of 9 has to be a 6. Multiple of 8 has to be a 4. So this comes pretty fast. For the 5, the multiple of 9 has to be a 4. The 7 actually has two options, 1 and 8. 14 and 84 are both multiples of 7, but 8 doesn't work for that clue over here. 80 or 88 would not work in the Sudoku sense. And so here we actually have to think about those multiple options, but 1 is the only thing that really fits, puts in the 6. Can now do a little bit of Sudoku. These 5s mean there's going to be a 5 in these cells, but if a 5 set here would have to be a multiple of 56, and the 6 is already over to the left, so that doesn't work. So for instance, 5 has to go in here, and progress like that. So this is a good place to start. And now it's about looking at the other boxes in the center to find the harder break-in, but still a meaningful break-in to get going. And I think cases where the same clue intersects were the theme that was here, and ending in 3s aren't as valuable because all digits, you can basically put any numbers here, but starting with multiples of 6s and starting with multiples of 7 are quite constrained things. And so these cells were the key ones to eventually focus on to get through this grid. Let's start in the bottom with a 7 to have two distinct multiples of 7 with the same first digit. It could be 2 with 21 and 28. It could be 4 with 42 and 49. And it could be 9 with 91 and 98. And you can work through those in your own sort of way, but that's very much a constraint that's in the grid. And you could say, well, that doesn't give me a lot of progress knowing that. Well, the thing to think about is as we were going through those, let's take 2 as a starting point. Got a 1 over here from Sudoku rules, and so this can't be the 21, this has to be the 28, and just working one more digit over, 8 would force an 81. And so the 2 is rolled out from the space, as is the 9. 9 would simply not allow a 1 here, has to be an 8 here, puts another 1 here. So this is tricky, but observable to be 4 with a 2. And a 9 pair. 9 doesn't work with a 9 because 90 and 99 don't work. So this has to be a 2, which gives this as a 7, forces this as a 9. 7 that's multiple of 4 is 72 or 76. The 2's in the grid already. 6 is a multiple of 4 is 64 or 68 because 60 is not going to go. And now we need to have 1 and 3 to finish the space. 51 and 18 work out, and 3 is a single, so that goes well. Let's come to this top, this other square. So two multiples of 6 that work with the same first digit. So 12 and 18, 42 and 48, 72 and 78. Those are the only ones that are out there. All the others can be excluded. 4 is already filled in down below. And as we said, this is going to be 2 and 8 as the digits that go over here. And so as we actually think through this, 2 of 8, Sudoku constraint forces us to be the 8, this to be the 2. 2 with a 7 is going to be 1 or 8, but 1's in the grid. Sorry, 8's in this box already, so this becomes the 1. That actually does force this as a 7. 1 with 8 makes this into a 6. With a 9 makes this into a 3. Multiple of 4 that starts with 8 is 80, 84, 88. The only one that works in Sudoku like this is 84. And multiple of 7 that works here is 42 or 49. The 2's in the box, puts in this 5. And so we get a good space here. We can now work into the last box in the grid before doing the other extremes of the puzzle, and that's probably easiest by starting through these columns. Like we have to get a chain of multiples of 3, and they're going to use the digits 1, 2, and 5. 1 and 5 adds up to a multiple of 3. 1 and 2 adds up to a multiple of 3. 2 and 5 do not. So 2 and 5 are the extremes with 1 in the center. The last digit of an even multiple always has to be 2, so we could also have said the 4 has to have a 2 up here, which puts in that 1/5 constraint. In this box we have, this looks like 3, 6, 8 to go, and that same thinking, the even values have to be here. Give you this with a 3 up top, and 68 is a valid multiple, but 86 is not. So we can do this. 8 is a multiple of 3, as a first digit is 81, which is in the grid, 84, 87. 3 is a multiple of 3 is 36, 33, no, 39. So this is a 4, 7 pair. And so there we're just going through a little bit of math and a lot of Sudoku and getting to this point in the grid. Let's now work into the top space. We've got 2 4s here that have to come over into one of these cells. If this was a 4, it'd be 54. That's not going to work, so the 4 is here. What is this multiple of 9? We have 1, 8, and 7 to go here, and so 7 has to be on its own because it's not going to add up to 9. This has a 1 down below. This has to be 81. In this space, we're going to have a 3 coming to the top. We're also going to have a 6 coming to the top. So those look like they have to be the part of the multiple of 9, and we have 5 on its own. So that's going to come over here. The 6 down below makes this 63. And in this space, we have 2, 7, and 9. And the only multiple of 8 in that space, we'll need the even number at its end, and 7 and 9 for this to go. We have an 8 here to finish this out, and not much more we can do up here. It's just 1, 2, 9. We got 5 and 5, pointing a 5 here and a 5 note here. 2 and 6, meaning this is a 4 or 8 in this cell. Let's see, this 8 coming across means there's an 8 over here. So this is actually a case where we know there's an 8 node across these cells. 8 can't start on 8 multiple because 80 and 88 are out. So this is actually the 8. Puts an 8 up here. We need to get an 8 in this space. Let's actually look across the way. Like looking across these rows was useful once we had things like this digit place. This is 3, 8, 9 to go. Which of those can be a multiple of 7? Well, 38 and 39 don't go, so there's not a starting 3 here, so this 3 has to come out. And now we have 9 and 8, and 89 doesn't work, but 98 does. So that makes this go. Moves this 5 down, moves this 5 up. 5 at the start of a multiple, at the end of a multiple 7 is 35 again. Puts in this 3. 5 as a multiple of 3 is 1 or 7 with the 4 up above. The space is 1, 2, 7 to go. The ones that work as multiples of 9 are 2 of 7 in some order, so the 1 is on its own. Down here we have 3, 4, and 6, and the 3 and 6 have to work to be the multiple of 9 with 4 on its own. At the top we have what we said before, 1, 9, and 2 to go. In this column we have 2, 6, and 9 to go, and 2 and 9 are to the left here, so this looks, it's actually a 4, 6, which puts in this 6. This is 2 or 9. Don't know more than that. Come to this multiple of 3 that starts with 8. This is another 4, 7, because the 1's over here, so this is 81, 84, 87, but there's a 4 up above, so this is now 7, 4, 7. Puts in 1, moves over this 1, puts in a 9, puts in this 2, 2, a 7. This is now the last 2. Puts in this 2, puts in this 2, 7 and 9 down here. You need to get a 9 in this space. You also need to get a 1 and 4 in the space. 48 is a fine multiple, so just checking that clue. 9 and 4 to finish this out. So a bit of a workout, but a good example for how to think through this style. So, you know, solvers will have a sense of what may be different challenges, but challenges like this for the Sudoku Grand Prix that's coming up. So hopefully you got a little bit of fun from mixing multiples with Sudoku, and if not, at least got a sense of the intended starts for this puzzle, not just these boxes which resolve on their own, but really these starting values that have to be shared 6 products and shared 7 products. Those are the most constrained cells for the digit space, and they force the rest of their rings, and that's how you work through this puzzle. Thanks for watching. We'll see you again soon.